Hi, in this video we are going to discuss about the proportional sampling. Firstly, we will go and discuss why we need the proportional sampling. Okay, then we are going to the how we can approach that one. For that, let's consider an example. Let's consider a list of elements. Here we have 5 elements. 1, 2, 3, 4, 5. 5 elements are there in the list, and the values are 2, 6, 1, 5, 20. Okay, if we use the random sampling technique, suppose if you use random sampling technique, the probability of picking every point will be same. Every element in the list will be same. And here we have 5 elements are there. The probability of picking any element is going to be 1 by 5. That is 0.25. Sorry, 0.2 only. And in the proportional sampling, the probability of picking an element is depends on the value it contains. For example, here we have the value of 1. That means the probability of picking that element is going to be very low. And the value of 20 it is the highest value in the list. And the probability of picking that point is going to be very high in this list. That is the basic thing about the proportional sampling. Let's start how we can achieve that one. In the first step in the proportional sampling, we are going to find the sum of the elements in the list. The first step, we are going to take sum of elements. Sigma I equal to 1 to n di. We are going to get 2 plus 6 plus 1 plus 5 plus 20 is equal to 34. And next step. In the next step, we are going to normalize this values. In the normalization, we are let's take like everything like the d1 dash, the first term. For this one, 2 by 34. We'll get 0.5 tablet. And similarly, d2 dash is 6 by 34. Here we will get 0.176. Sorry, here 0 more 0 is there. 0.05 tablet. In d3, we are going to take 1 by 34. We will get 0.029. In the d4 we have 5. 5 by 34 will get 0.147. In d5 we will take 20 by 34. Here we will get 0.5 tablet. In the next step, we are going to take cumulative sum of these values. Relative sum. Then we call d1 bar. d1 bar is equal to 0.05. Because no other element below that one. And d2 bar equal to d1 bar plus d2 dash. Now we will get 0.235. d3 bar equal to d2 bar plus d3 dash. Now we will get 0.2644. d4 bar equal to d3 bar plus d4 dash. So d4 dash we will get 0.4114. d5 is equal to d4 d5 dash. We will get the value of 1. Okay. Now, for example, if you take a random dot uniform, we already know about the uniform distribution. The value lies between 0 to 1, and the probability of picking any point will go into same between these range. And here also the range is going from 0 to 1. Now, if we call this function rand uniform, we are going to pick a point from this list by using that one. Okay, and every time we are calling, we are going to pick a point, and if the value is less than 0.058, we are going to pick the value that placed at 1, that located at index 1. And similarly, if the value lies between these two values, then we are going to pick second element. If we call uniform random once again, if the value lies between these two values, we are going to pick index 3. And similarly, if the value lies between 0.26 to 0.4111, we are going to pick fourth index value. And if the value lies between 0.4 to 1, we will pick the fifth element. Now, by observing, we can tell that the value lies less than this value, we are going to pick the value located at first position. Here, this one we will pick when the lies between these two. And here we can observe the difference between these two values is very less. Okay, that means the picking probability of 1 is very less. And coming to the last here, the difference is more here. Difference is more, that means probability of picking d5 is more. That means at position 5 the value is picking is more probability. Very high probability picking. By this way, we are going to use the proportional sampling technique, and we are going to achieve the proportional sampling.